Welcome back to Max with RP. We will continue with integration. We will solve problems using the simple technique of substitution. Look at the first problem. So, I am going to tell you a technique which will be applicable not only to do this problem, but problems of the form 1 by 1 plus cot x, 1 by 1 minus cot x, 1 by 1 plus tan x, 1 by 1 minus tan x. So for all these problems, this technique will work. So let us see what is the technique. So I am going to write I as integral of 1 by 1 plus, what do we have? Cot x. It's too thick. This I can simplify it. Cot x, I can write it as cos x by sin x, right? When I write cos x by sin x, I will get sin x into sin divided by sin x plus cos x. Cot x, I am writing it as cos by sin. So when I take sin to the numerator, I will get sin here and also here. So sin x dx by sin x plus cos x. See, the main technique that we use in integration is somehow or other we should be able to get the derivative of the denominator in the numerator. So for that I am going to use a particular technique. So what I am going to do is I am going to multiply and divide by 2. So this becomes 1 by 2 into 2 sin x dx by sin x plus cos x. Now this, what is the derivative of the denominator? Cos x minus sin x. Okay. So I need cos x minus sin x. So what I am going to do is I equal to half into I need cos x. What is the derivative? Suppose I take sin x plus cos x as t. I need cos x minus sin x. So I am going to write it as minus half into 2 sin x dx by sin x plus cos x. Now this is further sin x plus cos x. So I am going to have cos x minus sin x. Okay. So what have I done? And write one more integral. I have added cos x. I am going to subtract cos x, and already I have minus sin x. See, what I have here is minus 2 sin x. So I can write minus sin x. I have added cos x here, so subtract cos x divided by sin x plus cos x. So now simplify the numerator. Cos x minus sin x is equal to minus 2 sin x. So I have added and subtracted cos x. That is what I have done, and split it into two integrals. Now, if I put sin x plus cos x as t, suppose sin x plus cos x is t, then cos x dx minus sin x, cos x minus sin x dx will be dt. So I will be minus half dt by t plus half, or I can take out that minus sign common, minus half into sin x plus cos x. Now derivative of cos x is minus sin x. So I already have minus sin x. Right? And then I have, take out that minus outside, then it becomes sin x plus cos x So this is 1. So minus half log mod t plus half into integral of dx, which is equal to half minus half log mod, what is t? Sin x plus cos x. Okay, then what do I have? This is what? This is 1. So integral of dx will be plus half x plus c. So minus half log mod sin x plus cos x plus half x plus c. So what is the technique we are doing? Multiplying, dividing by 2, then adding and subtracting cos x. 1 becomes this, if I take out minus, this becomes 1. So integral of dx, here the numerator becomes the derivative of the denominator. So I can use the process of substitution. Is it clear? Is this problem clear? Now let us try this. Integral of 1 by x into root of x power 4 minus 1 dx. I am going to put x power 4 minus 1 equal to t. Then 4x cube dx will be dt. But I don't have 4x cube, so I am going to multiply and divide by 4x cube. So this is, okay, for multiply and divide by 4x cube, 1 by 4 into 4x cube dx. If I multiply the numerator, I need to multiply the denominator also. So x cube into x will give me x power 4 into root of x power 4 minus 1. Now I am going to write this in terms of t. So this will become equal to half into integral of 1 by 4 into 4x cube dx is dt by x power 4 is what? T plus, what is x power 4? T plus 1. And what is root of x power 4 minus 1? X power 4, this is root t, isn't it? Since I have taken x power 4 minus 1 as t, in fact I am going to put it as t square. So I can avoid the square root. X power 4 minus 1 as t square. Then 4x cube dx will be 2t dt. Okay. Now this becomes, I multiplied and divided by 4. So 4x cube dx is 2t dt divided by, this is what? X power 4 t square plus 1. Okay. Now t square plus 1 into, what do you have as root of x power 4 minus 1? Root of t square, which is t. So t and t gets cancelled, 2 gets cancelled. So half into integral of dt by t square plus 1. You all know, if y equal to tan inverse x, dy by dx is equal to 1 by 1 plus x square. So integral of dt by t square plus 1 is nothing but this is half into tan inverse t, which is half into tan inverse, what is t? Root of t square is this, t is root of x power 4 minus 1 plus c. So I have 1 by x into root of x power 4 minus 1. X power 4 minus 1 I am taking as t square. So 4x cube dx becomes 2t dt. I am multiplying and dividing by 4 and also x cube. So 4x cube dx comes in the numerator. Denominator I already have x. So when I multiply by x cube, it becomes x power 4. So that is how you get this expression. Then substitute for t. 1 by 4. 4x cube dx is 2t dt. Already you have 1 by 4. x power 4 is t square plus 1, and then root of t square, which is t. So this t gets cancelled, 2 gets cancelled, giving you half into dt by t square plus 1. Recognize that the derivative of tan inverse x is 1 by 1 plus x square. So integral of antiderivative of 1 by 1 plus x square will be tan inverse x. But here we have t, so half tan inverse t, which is half tan inverse root of x power 4 minus 1 plus c. Now let us look at this problem. Integral of cos power 9x dx by sin x. See, I know that the derivative of sin x is cos x. So I am going to keep 1 cos x dx for my substitution purpose. So what will I be left with? Cos power 8x by sin x. This is my I. Now this is integral of cos square x the whole power 4 by sin x into cos x dx. Now this is integral of cos square x is 1 minus sin square x. 1 minus sin square x the whole power 4 by sin x into cos x dx. Now put, let sin x be y. Okay, if I put sin x as y, cos x dx equal to dy. Okay, now I will become integral of 1 by y. So what have I taken as y? Sin y. So sin x. So 1 by y square the whole power 4 divided by y, because sin x is y, cos x dx is dy. I have already written the expansion. If you know binomial, you can use binomial. Otherwise, you can just expand a minus a. First you square 1 minus y square the whole square. You will get 1 plus y power 4 minus 2 y square. Then it becomes a plus b plus c the whole square. It is a square plus b square plus c square minus 2ab minus 2bc minus 2ca. So that is what I have used to expand this. So I will be equal to integral of 1 minus 4y square plus 6y power 4 minus 4y power 6 plus y power 8 divided by y dy. 1 minus 4y square plus 6y power 4 minus 4y power 6 plus y power 8. Now if I divide by y, I will get integral of 1 by y minus 4y plus 6y cube minus 4y power 5 plus y power 7 dy. 1 by y minus 4y plus 6y cube minus 4y power 5 plus, this is y power 8 by y is y power 7 dy. So when I integrate, I will get I equal to, final answer, integral of 1 by y is log mod y, okay, minus 4 into y square by 2 plus 6 y power 4 by 4 minus 4 y power 6 by 6 plus y power 8 by 8. Plus c, where what is y? Substitute y equal to sin x. So we have written cos power 8x as cos square x the whole power 4 into cos x, written cos square x as 1 minus sin square x, taken sin x as y, expanded 1 minus y square the whole power 4, then integrated it term by term. Is it clear? Now, integral of cos power 5x dx. Now, after doing the previous sum, this should already give you a clue. Keep it as cos power 4x into cos x. Why? Because this I can write it in terms of sin x, and if I put sin x as t, cos x dx will be dt. So that is that underlying logic or technique. So this is integral of 1 minus sin square the whole square, cos square x the whole square. Cos square x is 1 minus sin square x into cos x dx. Let sin x be t. Then cos x dx will be dt. So I will be equal to integral of 1 minus t square the whole square dt. This is integral of 1 plus t power 4 minus 2t square. I expanded this into dt. Term by term integration, this is t plus t power 5 by 5 minus t cube by 3 plus c, where t equal to sin x. Please substitute it back for sin x. I have written t equal to sin x, but you can actually replace t by sin x. Are you all able to follow? Now look at this. Integral of root tan x by sin x cos x. I am going to again make a manipulation here. When I see this tan x, I feel that I need tan x in the denominator also. So what I am going to do is, this sin x I am going to divide by cos x. Then what will happen? Here it will become cos square x dx, because if I divide I have to multiply. Now if tan x is t, we know that secant square x dx will be dt. So I will be equal to integral of, okay, now root tan x by tan x, right? So 1 by cos square x is secant square x. This is also tan x. So root tan x by tan x will give me root tan x dx. So this will be of the form dt by root t, which is integral of t power minus half dt will give you t power minus half plus 1 by half plus c. This will give me 2 root t plus c, which is 2 root of tan x plus c. So this involves this manipulation, multiplying and dividing by cos square. Conveniently you get cos square 1 by cos square x, which is secant square x, which is the derivative of tan x. Is it clear? Are you able to follow? Integral of sin x minus cos x, but here the interval is given as 0 to pi by 4. Now look at the denominator. I have 1 plus sin 2x. I can write it as cos square x plus sin square x plus 2 sin x cos x. But this can be written as sin x plus cos x the whole square, or cos x plus sin x the whole square, which doesn't matter. But this is cos x plus sin x the whole square. So when I take square root, it will become cos x plus sin x. So I will be integral of sin x minus cos x by cos x plus sin x is the same. If I take the root, it becomes sin x plus cos x. Derivative of sin x is cos x. Cos x derivative is minus sin x. So I can write it as minus of, okay, what will I have? Cos x minus sin x. Minus sin x into minus will give you plus sin x. Divided by sin x plus cos x. Put sin x plus cos x as t. Then cos x minus sin x dx equal to dt. So I will be minus integral of dt by t minus log mod, what is t? Sin x plus cos x plus c. Are you able to follow? Minus log mod sin x plus cos x plus c. So today we saw a few sums using the technique of substitution. How technique of substitution helps us to describe the given function or simplify the given function into a form that you can identify, the integral value of which you can identify. Okay, I hope you found it useful. Do not forget to subscribe and share it with your friends if you found it useful. Thank you. Until we meet next time, it's goodbye.